Model for assessing synergy in the manufacturing business organization. The contemporary manufacturing business organization operates in an environment characterized by accelerated technological development, digital transformation, and increasing market dynamism. The transition to Industry 4.0 and Industry 5.0 is transforming traditional manufacturing systems into integrated cyber-physical production environments, where an organization's competitiveness depends not only on the availability of production resources but also on the capability to integrate, coordinate, and manage these resources in a manner that generates a sustainable synergistic effect. The contemporary manufacturing business organization is founded on several fundamental principles. Systemic integration of production and management processes. Digital connectivity and interoperability between physical and cyber components. Adaptability and flexibility in response to changes in the external environment. Information-driven managerial decision-making based on reliable digital data. Synergistic interaction between the physical production environment and the digital infrastructure. Optimization and sustainability of production processes. A human-centric approach that preserves the leading role of people in the management, control, and continuous improvement of manufacturing systems. Within this context, synergy has become one of the key determinants of organizational efficiency and competitiveness. It reflects the ability of a manufacturing business organization to generate outcomes that exceed the cumulative contribution of its individual resources through their coordinated interaction and optimal utilization. Consequently, the assessment of synergy requires a comprehensive analysis of the organization's resource potential and its capacity to transform this potential into sustainable competitive advantages over the long term. The resource potential of a manufacturing business organization constitutes the foundation for assessing its synergistic capacity. This potential is determined by the availability of production resources, the organization's ability to commercialize its products and transform them into financial resources, and the time horizon over which it is capable of maintaining its effectiveness, efficiency, and profitability. Assessing the potential for achieving a synergistic effect over the long term necessitates the development of an integrated model that accounts for the interrelationships among the resource potential of the manufacturing business organization, the time factor, and the expected synergistic outcome. In this regard, the present study proposes a model for assessing synergy in the manufacturing business organization, which provides a methodological framework for evaluating the organization's resource capabilities, determining its synergistic potential, and supporting managerial decision-making aimed at enhancing organizational effectiveness, efficiency, profitability, and the long-term competitiveness of the manufacturing system. The model for assessing synergy in the manufacturing business organization is an original management tool developed to support strategic managerial decision-making related to evaluating the appropriateness of managerial decisions. Its purpose is not only to measure the potential for generating a synergistic effect but also to identify the resource-related, process-related, and organizational prerequisites that determine the economic efficiency of any organizational change. In this respect, the model possesses both analytical and predictive characteristics, as it combines the assessment of the organization's current state with the forecasting of future outcomes. The sequence of the individual stages is not arbitrary. Each subsequent stage builds upon the results of the preceding one and progressively extends the analysis, from describing the organization's current state, through forecasting and economic evaluation, to the final determination of the presence or absence of a synergistic effect. In this way, the model functions as an integrated decision support system for strategic managerial decision-making. The proposed model comprises 8 sequential stages that together form a comprehensive process for analysis and decision support in strategic management. The first stage is of fundamental importance to the reliability of the entire model, as every subsequent forecast depends on the accuracy of the assessment of the manufacturing organization's current state. For this reason, the analysis should encompass not only the quantitative characteristics of the available resources but also their quality, degree of utilization, interdependence, and capacity to support the future process of digital transformation. Resources are therefore not considered as isolated elements but as interconnected components of an integrated organizational and production system. The first stage focuses on assessing the current state of the manufacturing business organization. At this stage, the quantity and quality of the available resources, business processes, organizational relationships, and achieved economic performance are analyzed. To ensure a comprehensive assessment, the model incorporates the 3R model, in which R1 represents the organization's resources, material, financial, technological, and human, R2 represents production processes and organizational relationships, and R3 represents organizational results, measured by production output, productivity, profit, sales, or other indicators of organizational performance. The second stage of the model for assessing synergy in the manufacturing business organization is aimed at forecasting the period during which the manufacturing organization is expected to maintain its profitability and competitiveness. The primary objective of this stage is to evaluate the extent to which the existing manufacturing architecture is capable of ensuring sustainable operation under dynamically changing environmental conditions. The third stage of the model focuses on forecasting the investment required to implement the planned organizational transformation. When estimating the required investment, several major categories of risk should be taken into consideration. Investment risk refers to the possibility that the invested resources may fail to generate the expected economic return. Technological risk arises from the rapid evolution of digital technologies and the possibility that the selected technological solutions may become obsolete within a relatively short period. Organizational risk is associated with the need for changes in the organizational structure, business processes, and management practices, which may encounter resistance or require a substantial adaptation period. In addition, a significant component of the investment involves the development of a reliable digital infrastructure that ensures connectivity, data exchange, cybersecurity, and seamless integration between the physical and digital components of the manufacturing system. The fourth stage forecasts the future state of the organization's resources, production processes, organizational relationships, and expected economic performance following the completion of the transformation process. This stage provides an assessment of the manufacturing system's anticipated organizational performance after the implementation of the cyber-physical architecture. The fifth stage determines the investment payback period using the following relationship. Following the calculation of the investment payback period, the economic efficiency of the investment decision should be evaluated. The payback period is one of the most widely used indicators in investment analysis, as it provides a clear measure of the time required to recover the initial investment through the net cash flows generated by the project. The sixth stage evaluates the effectiveness of the organizational transformation by comparing the period during which the organization is expected to remain competitive without restructuring with the investment payback period. For this purpose, the following coefficient is used. A positive value of the coefficient indicates that organizational restructuring represents an economically justified strategic alternative. A negative value indicates the need for the timely implementation of restructuring measures, whereas a value equal to 0 suggests that the final decision should be made only after analyzing the results obtained in the subsequent stages of the model. The seventh stage determines the potential improvement of the manufacturing business organization resulting from the restructuring process. The potential improvement, N, is calculated as the difference between the projected organizational performance after restructuring and the current organizational performance prior to its implementation. The final, eighth stage is intended to determine conclusively whether synergy is present or absent. Synergy is considered to exist when the potential improvement has a positive value, N0, indicating that the implemented change within the manufacturing business organization creates additional value. When the value is negative, N0, no synergy is observed, and the investment in organizational transformation is not economically justified. When N equals 0, no synergistic effect is identified. However, this result indicates that the organization utilizes its resources, processes, and organizational relationships with the highest possible level of efficiency, regardless of the selected development strategy. The final, eighth stage is intended to determine conclusively whether synergy is present or absent. Synergy is considered to exist when the potential improvement has a positive value, N0, indicating that the implemented change within the manufacturing business organization creates additional value. When the value is negative, N0, no synergy is observed, and the investment in organizational transformation is not economically justified. When N equals 0, no synergistic effect is identified. However, this result indicates that the organization utilizes its resources, processes, and organizational relationships with the highest possible level of efficiency, regardless of the selected development strategy. Synergy should not be reduced solely to the achievement of higher profits. Its manifestation is reflected in increased labor productivity, reduced production costs, shorter production cycles, improved product quality, enhanced reliability of production processes, and the creation of conditions for the sustainable development of the manufacturing organization. The model for assessing synergy in the manufacturing business organization developed by the author provides the basis for drawing the following key conclusions. The model integrates resource analysis, investment evaluation, and the quantitative measurement of synergy into a unified conceptual framework. For the first time, the synergistic effect is interpreted as the outcome of the simultaneous interaction among organizational resources, production processes, organizational relationships, and the time horizon of the restructuring process. The application of the efficiency coefficient and the potential improvement indicator provides an objective basis for evaluating the economic feasibility of organizational change in the manufacturing business organization. The model has a high degree of practical applicability and can be employed as a strategic management tool in the context of Industry 4.0 and Industry 5.0. The integration of resource-related, organizational, investment, and technological factors establishes the proposed model as a comprehensive framework for supporting managerial decision-making in the manufacturing business organization.